Hello students, previous class we discussed about the correlation and methods of correlation. In that methods of correlations, previous class I covered scatter diagram method, graphic method and rank correlation method and Cole-Pearson coefficient correlation method. So, yesterday already Cole-Pearson coefficient correlation already we covered. Today I am going to cover about the rank correlation according to Spearman-Coty correlation method. So, before that, so previously already we calculated correlation. Now, what is the difference between previous correlation and this rank correlation? See, whatever variables they are given, here we are going to assign the ranks. So, based on the ranks we are going to calculate the correlations. So, whatever the variable is there, first we have to assign the ranks based on the ascending or descending order. After that, we have to calculate the deviation between the ranks. Then we have to calculate the deviation square. So, with the help of the Spearman-Coty rank correlation formula, we are going to substitute the values, then we get the correlation value. So, this is the correlation Spearman rank correlation introduction. So, here we are going to measure the strength and direction of the two variables. Here we are going to calculate, we are going to use the data, ordinal data, and also we are going to use the linear data only we are going to use. So, based on that, the statistical measure used that access the strength and direction, we are going to take the direction of the monotic variables. We have to find the relationship between the two variables. It is a non-parametric test. So, there are three types of problems are there according to Spearman rank correlation. First, when the ranks are given, only ranks when they given, we have to calculate the correlation. If they are not given ranks, how to calculate the correlation? Second method, when the ranks not given, when the data only they given, so how to calculate the correlations? Third method, when the equal ranks are there, when the ranks are repeated, so how to calculate the correlation? That is we are going to cover in this chapter. First one, when the ranks are given, only ranks given, this formula we are going to use, that is R is equal to 1 minus 6 sigma d square divided by n into n square minus n1. So, this one also we can use, instead of this n into n square minus 1, n cube minus n also we are going to use. So, let us see that one example. First example, they given ranks of the 10 students. Here ranks of the 10 students subject wise A and B. So, given below and calculate Spearman's correlations. So, these all the variables are ranks. These all the variables are ranks. Between this, using of these two ranks, we have to calculate the correlation. So, only here the data not given, only instead of data set they given only ranks. So, with the using of that ranks, we have to calculate the correlation. So, six, 5, 3, 10, 2, 4, 9, 7, 2, 4, 9, 7, 8, 1, 8, 1. These are the ranks which are there in A series. And similarly, for B series also 3, 8, 4, 9, 3, 8, 4, 9, 1, 6, 10, 7, 1, 6, 10, 7, 5, 2. So, these are the ranks. So, here they given direct values only. So, A series they given ranks and B series also they given ranks. Now, what we have to do? So, direct here direct we have to calculate the difference of the ranks. So, rank 1s and rank 2, A series we treated as a rank 1, B series we treated as a rank 2. So directly you can R1 minus R2, D is equal to R1 minus R2. Here I am calculating the difference of ranks. So we are talking about the first method, when they given direct ranks, how to calculate the correlation according to Spearman rank correlation. So first ranks I taken and difference I am calculating. 6 minus 3, 5 minus 8, minus 3, 3 minus 4, 1, minus 2, 1, 0, 3 and minus 1. So this is the difference of the ranks. So after calculation of the deviation, we have to do the square value, d square, that is 9, 1, 1, 1, 4, 1, 0, 9 and 1. So this is the aggregate of the total value, 18, 20, 21, 25, 26, 36. So this is the sigma d square value. So here you can take direct value as well. Just you can substitute 1 minus 6 into 36 divided by number n is equal to number of variables, that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 variables. So total 10 variables. So you can write like this, 10 cube minus 10, or you can write, instead of that writing, 10 into 10 square minus 1. So you can use anything, both are, you will get the same. So I am following this one only. So 6 into 36, that is 1 minus 6 into 36, 6, 180, 180 plus 216, 216, 216. So here next one is the 10 cube, 10 into 1000 minus 90. So that is next one, this is 216. After that 10 cube minus 10 or 1000 minus 10. So that is 990. So next step, 1 minus 216 divided by 990, 216 divided by 990. So that is next step, 1 minus 216 divided by 990, that is 0.218. The whole simplification, 1 minus 0.218, the value is 0.782. So this is the R value. So therefore R is equal to 0.782. So it is more than 70%, there is a relation. It indicates that high positive correlation is there. So this is the correlation according to Spearman rank correlation. So in this problem what I have explained, when they given ranks directly, so this is the way to calculate the correlation. Now second method we are going to discuss. So instead of giving the ranks, if the given data series between the two variables, when the given data series in the two variables, how to calculate the correlation. So that time, so this is the previously which I explained that. Simply ranks I taken, ranks 2 I taken, difference I calculated, and the difference what I calculated I did square, I substituted in the formula, so I will get the correlation value. Now we go for the second method, that is when the ranks are not given, when the given data set only, how to calculate the correlation. So now let us do that. See, second method where ranks are not given, how to calculate the correlation. So this is the problem we are going to solve right now. Okay. Now I will explain x variables 60, 40, 80, 60, 48, 52. X, Y. Yeah. Now we are going to talk when the ranks are not given, how to calculate correlation according to Spearman rank correlation. Now I will explain with the help of this example problem. So x variables 60, 60, 48, 52 and 50, 55 and 62, 65, 70, 68. So this is the variables of x. Now variables of y 72, 62, 68, 65, 70, 60, 55, 52, 79. 9
variables, na?
Yes,
10 variables.
9. So this is the problem. First, whatever the data given, we have to assign the ranks. Previous problems, what happened? Direct ranks only they given. But in this problem, only data set they given. So that data set, we have to arrange the ranks. So ranks, how we are going to assign that? Based on the highest one to lowest one. For example, in this X series, which one is the highest? So 70 is the highest. So I am going to assign the rank 1, R1, that is 70, first rank. After 70, 68, second rank. After 68, 65, third rank. After 65, 62, fourth rank. This is the fifth rank. After 60, 55, sixth rank. After 55, seventh rank. After 52, this is the eighth rank. This is the ninth ranks. So here I assigned all the ranks. Similarly, same I am going to assign for Y series also I am assigning the ranks, that is R2. So which one is the highest one? Here 79 is the highest one. This is the rank 1. After 79, next one is the least one is 72. So that is second rank. After 72, 70 is the third rank. After 70, here 68 is there, that is fourth rank. After 68, this is the 65 is the fifth rank. Here after 65, 62 is the sixth rank. Next after 62, least one is this one is the seventh rank, this one is the eighth rank, this one is the ninth rank. So what I did here, simply based on that values, data sets, I arranged that ranks. I assigned the ranks. Next, as usual, previous whatever steps we followed, same steps here also applicable. Next, we have to find out that R1 minus R2. So you can take R1 minus R2 or R2 minus R1. Here we required only difference ranks only. Is it clear? So 5 minus 2, that is 3. 9 minus 6, 3. 7 minus 4, 3. 8 minus 5, 3, 6 minus 3, and 4 minus 7, again 3, and 3 minus 5, 1 minus 8, 2 minus 1, 1. So, this is the difference of ranks. So, after calculation of difference of ranks, this is D. So, next one is after calculation of D, D square. So, this is 9, 9, 9, 9, 9, 9, 25, 64, 1. So, here if you observe that D square value, whether it is plus value or minus value, when you are calculate that square, it will come positive value only. So, that is the reason here you no need to worry about the whether it is positive or negative. So, whatever the difference value is there, that value only you have to consider. So, after that you can just sum of this. So, this is all 9, 9, 9, 9, 9 total fee here 9 plus 18, total amount of that 144. So, aggregate of the D square is 9, 144. So, just you can substitute the formula. So, that is R is equal to 1 minus 6 sigma D square divided by n cube minus n. So, simply 1 minus 6 into 144 divided by 9 cube minus 9. Next step 1 minus, so 6 into 144, that is 864, 864 divided by 9 cube means 9 into 9 into 9. So, 9 into 9 into 9, that is 729 minus 9. So, next step 1 minus 864 divided by 720. So, that equals to 864 divided by 720. So, 0.1 minus 1 2. So, this is after 1 minus 1.2 minus 20. So, this is negative correlation. So, here the association between these A and X and Y variables, there is a low negative relationship is there. So, there is negative association between the X and Y variables. This is the way to calculation of when the ranks are not given in the problem. We have to assign the ranks, we have to calculate the deviation, we have to calculate the deviation squares. After that, we have to substitute the values in the formula, then we can calculate the correlation. So, this is the second method. As of now, we discussed about the Spearman rank correlation. When the ranks are given, first method we calculated correlation. Second method, when the ranks are not given, if they given only data set, we assign the ranks and we calculation correlation. Third method, according to Spearman rank correlation, when the ranks are equal is there, how to calculate the correlation, in third method we are going to discuss. So, here when the ranks are equal, how to calculate that? So, that how to calculate the R in when the ranks are equal is there. So, we are going to calculate that. For example, see from this data, if you observe that X and Y variables, in X variables 60 repeated 3 times. So, it means what? Instead of giving 3 ranks, we are not able to assign the ranks. So, 60 repeated 3 times, same rank got for the 60. And in Y series also, if you observe the data set, 35 repeated twice. So, it means what? Same rank we are going to assign. So, previously that ranks are not equal and repeated ranks are not there, but in case we have repeated ranks. So, how to do the correlation when the repeated ranks are came, I will explain now. Yeah, with the help of one problem I am going to explain. I am writing the problem x this is the problem. If you observe that two data sets x and y, some of the variables are repeated. It is very difficult to assign the same rank for that all the variables. So, in this case we have to follow some procedure to give the assign the ranks. So, now I will give the ranks first one. So, that is first highest one is the in x series 1. So, rank 1 is equal to this is the first one. After 70 there is a rank. After 70 we have to assign two second rank for the 60, but in this case the 60 variables are 3 variables are there. So, first one is the 60, next also 60 is there, total 3 variables are there. It means what? Rank 2 and rank 3, rank 4. So, these ranks we have to take and we have to take the and give the average ranks. So, 2 plus 3 plus 4 total 9. So, that 9 for the 3 variables, here 3 variables covered. So, on an average for each one we are going to assign the 3 rank. So, for rank 60, 3, 3 and 3. It means what? Already second rank over, third rank over, fourth rank over. Next fifth rank after 60, what is the rank is there? This one 55 is there. So, again we are not going to give the 4 because that 3 ranks average only we are taking. Second is over, third is over, fourth is over. Now, fifth rank as usual I am going to assign, and sixth one is the here 7, 8. So, this is the way to assign the ranks. In Y series, when R2 is there, first highest one is first rank. So, among these all the variables 60 is the highest one, that is rank number 1. After 60, 50 is there, that is rank number 2. After 50, 48 also there, 3. After 48, 42 also there, that is 4th rank. After 42, 40 also there, 5th rank, and 6th, 7th. Next one is the after 5th, this one is the 6th, 7th and 35, 35 repeated twice. So, rank 7 and rank 8. Average ranks we are going to give. 7 plus 8, that is 15 by, it is repeated 2 repeated values, that is nothing but a 7.5. This 7.5 we are going to assign for the 35 and here also 35. So, it means what? We are assigning the average ranks for the repeated values. So, after calculation, after assigning the ranks, similar procedure is same, that is difference of R1 minus R2. So, first 3 minus 5, that is 2, and 5 minus 2.5, and 3 minus 3, 3, 1 minus 4, 4, 3, 6 minus 1.5, 7 minus 2, 5, 8 minus 5, 3 minus 1, 2. So, this is the D. D is nothing but a difference amount of ranks between the ranks. So, already this is help to know how to give the ranks. So, after calculation of D, D square we have to do it. So, I am removing this one. So, Next one is the d square. 4, 2.5 into 2.5, that is 6.25. 9, 1.5 into 1.5, that is 2.25. 25, 4. So this is d square aggregate value is equal to 84.5. So this is the d, sum of d. Now when the ranks are equal, this is the different problem. So here the formula is different. The formula is, here we are going to use r is equal to 1 minus 6 sigma d square plus 1 by 12 into m cube minus m plus 1 by 12 m cube minus m at n number of we are going to write. So how many repeated, that many times we have to write. Is it clear? M cube minus m. So here for example, first series 3 times we repeated. So we are going to take here 3, and second series 2 repeated, 2. If any number repeated once again continuation it will come. So this formula is 1 minus 6 sigma d square plus 1 by 12 m cube minus m. So in place of m, n number of will come. It is depends on the problem. So I am going to substitute that 1 minus 6 84.5 plus, so 1 by 12 is the formula as it is, 1 by 2 is the formula as it is, into m cube minus m. Here this 60 how many times repeated? 1, 2, 3, 3 times repeated. So in place of m you have to write 3 cube minus 3 plus 1 by 12 again same. So this series is over. Next series is what? In y series 35 repeated twice. So instead of 3 you can write 2 cube minus 2. So this, after that as usual n cube minus n. So just simplify this data, 1 minus 6 into 84.5 plus, here 3 cube 27. So 1 by 12 into 27 minus 3. Next 1 by 12 into 8 minus 2. 8 minus 2. N cube how much? Number of variables 1, 2, 3, 4, 5, 6, 7, 8. So here also I have to write first 8 cube minus 8. Here also 8. So after that next step is 27 minus 3, 24. Just you can simplify this data. 12 in 12 ones are 12 twos are 2. Direct you can write 1 minus 6 84.5 plus. So here I am taking the total value 27 minus 3 24. 12 by 12 is there. Here I am going to take 2 direct value. After that here 12 is there, 8 minus 2 6, 0.5 is the value, that is, so 0.5. Next step 83 minus 8. So 1 minus 6 into 84.5, you can sum of this value total at a time. 84.5 plus 2 86.5 plus 0.5 87. So, that is 87 is the value, and next one is the 88 the 64 into 8 521 minus 8 504. So, this is the value next last step 1 minus 6 into 87 that is 522 divided by 504. So, what is the value 522 divided by 504? That is 1.03. So, this we can write 1 minus 1.03, that is value of 1 minus 1.03. So, minus 0.03. So, this is the negative correlation, again very low negative correlation is there. So, this is the way to calculate the correlation when the ranks are equally there, when the ranks are repeated, we have to use this formula, then we can calculate the correlation. Here n number of ranks repeated, that many numbers we are going to take here. This is the correlation according to the Spearman rank correlation. Thank you.